I work as a software engineer at MinDoctor. And I've been working on doing websites and web applications since '98, I think I started. Most of the time I spent in Copenhagen, but the last 5 years I've been working here in Malmö. So a little bit about MinDoctor. We're a digital caregiver. Based in Malmö, we have some 30 doctors connected to our network, and they are real doctors, not machines, not artificial intelligence or anything like that. And so they can give recommendations, do prescriptions, and referrals to things like you need to test for. And basically, so we take privacy and security pretty serious at the company. And let's see. Yeah. So basically, this thing came about on a quite recent project where we looked into supporting Safari and iOS specifically, and their private mode. Everyone is aware of what private mode is in Safari, I guess. No? Hands up? 1, 2, 3, 5, 12. So, and this is not the first time I've been sort of knee deep into figuring out things from a front-end perspective, and security, cookies, what happens if you end up with an attack or something like that. And every time I've been thinking okay, I'm gonna do some research on this one later. I'm just gonna fix this bug first, and then continue with doing whatever JavaScript and HTML and CSS, which I'm better at. But I'm going to come back and do some proper research on this, which has never happened. So I figured I'd do this time. And like most of you guys have read and seen, people are talking a lot about JavaScript fatigue. There's a new framework coming out every week, and there's a new React router coming out, and which is much better than the previous version, and so on. And while doing some reading on security, I sort of found myself, we're not the only ones. I sort of felt like I stumbled into something that's called, I mentioned, it's more like a security fatigue. It's a challenging topic to research if you have some procrastination tendencies like I do. It's like, oh, look, an article of things I don't understand. I'm gonna and then I'll lose a half an hour reading something and get back to the topic, and I still haven't got what the previous one was about. And for every article proposing a good solution to security, privacy, and so on, there's a ton of contradicting arguments, both contradicting articles and comments, and they are made by really smart people. And I have zero hacking experience. But we, as front-end devs, we have an edge. We sort of mastered CSS at one point of time, and think like, okay, if we can do this, anything is possible. And also, it helps putting on a paranoid mindset. That goes a long way when thinking about security, because I figured out if you don't have to be able to actually do any hacks, because if you can think something up, then someone will know how to do it or figure out a way to do it. So let's start off with a short history about the cookie. I think everyone knows what a cookie is. Yes, good. So basically, the first specification of the cookie was a 4-page document written in '94 by a guy called Lou Montulli. He was working at Netscape. Netscape was one of the biggest browser vendors at the time, and I think he mentioned in an article somewhere there were like 14 people at the office in '94. So it's a bunch. The term cookie derives from the term magic cookie, which I read is a term used by Unix programmers to to talk about the package of data that is delivered from one piece to another piece and goes untouched. And that magic cookie term is in turn derived from a fortune cookie. It's a cookie that has an embedded message. So Netscape, they released this one end of '94 and started using it, and the spec was like really short. But Internet Explorer, the other browser that was popular at the time, they jumped on the bandwagon and it came out in version 2.0. They had in October '95 it came out. And then a lot of things happened, which I'm going to come back on next slide. So the first specification, a more proper one, was released in '97. And in 2000, there came a revision of that. 2002, Microsoft proposes HTTP-only cookies because there was a lot of issues with the regular cookies at the time. And 2005, HTTP-only is included in IS6. And the specification we have today with the cookie is was written in 2011. So I guess during this time, privacy came as an afterthought. I think the major draw for making the cookie was that they were building some kind of an e-commerce system, and they just needed something to be able to store where you were, which you often do with cookies. But they sort of forgot to tell people about it. So an article called "This Bug in Your PC is a Smart Cookie" came out in Financial Times in '96, and that's kicked up a whole list of things, both politically and also people in the business, and got people's attention. It's like it's kind of scary. Nobody's told us about it, but they're tracking us. So there was an internet engineering task force that started working on a specification. And it felt kind of rushed, perhaps, but it came out in October '97. And in the specification, there was a recommendation, a pretty strong recommendation, that third-party cookies were not allowed, or at least not labeled by default. I guess most of you recognize that. And the problem was that there were advertising companies already using cookies, big scale, big time. So the recommendation was ignored by Netscape and Internet Explorer, so everyone carried on their way. And if you look at this latest one that came out in 2011, we nowadays explicitly allow user agent to implement whichever strategy, a cookie policy they wish. And there's been other political weirdness about cookies. The EU cookie directive in 2011 was also something that sort of feels like a privacy afterthought, putting Band-Aid on the knee. And it's sort of like before somebody can store or retrieve any information from a computer or device, you must give an informed consent to do so. And that's sort of old news, out of scope for this talk. And it looks like, and I've been working more like with product and applications, less and less with websites the last 6 years or something. So, but I guess all the fuss around the cookies, it seems to have been like, okay, if you by continuing with the website, you approve that we are tracking you. And it was kind of unclear, and this is more like a question to you guys for later. A session cookie would probably be okay anyway, right? If you log into a web page. There's also been some other tries on fixing privacy. A thing called P3P, a great idea, but somewhat weirdly executed. You could put you can state your privacy policy using an HTTP header, And the way the HTTP header was supposed to look like is kind of this p3 and then the content, and then you were supposed to be using all the abbreviations that you could find that fitted your business the best. I and Edge are the only browsers implementing it. Google's response was maybe not the best one, and Facebook at times had this metadata on their web pages and all their example pages as well, because you could put whatever here just to apply to the privacy preference. So honk was a good thing. All right, back to cookies. A cookie is a small text file stored in your browser, and it contains a name-value pair, and that is the actual data. And then you have the possibility to set an expire state, after which a cookie is no longer valid. You can have a domain and a path of the server it should be sent to, and you could add secure to only allow the cookie to be sent on HTTPS. And if you don't specify any expires, then it will be expired at the end of the session. And cookies are sent as a header, and a cookie is only sent to a destination where it's allowed for, and you set that with the domain and the path. And for the server, a cookie is just that. It's a HTTP header, nothing else. And the directive that came out in 2002, in order to fix some privacy and security issues, was the HTTP only thing, which sort of prevents a cookie from being read client side. So you can only set the session cookies from the server, and it's invisible to the JavaScript client. So this is really clear. They had a lot of specifications about what you can do and what you can't do and so on. But there are some ambiguities. Like, when does a session cookie expire? Well, in 2000, where I'm not sure you had browser tabs, you have like a browser window and you close the browser when it was finished. Then it was pretty clear. It's when you close the browser. But today, I don't know about you, but I just closed the Chrome window just prior to keep the thing, and I had like 8 windows with 7 tabs in each or something like that, and it stays like this for a week on my machine. I'm probably a bad person doing it, but that sort of means that a session cookie on my machine could take a week before it expires, because I don't close the browser, I just close the tab. And if I just close the tab, I don't remove the session cookie. Also, can a secure cookie be set from an HTTP page? That is, you can write document.cookie and then just add a semicolon and secure. And it turns out in Chrome at least, you can. So you can set a cookie from an HTTP page that only shows up on an HTTPS page, which is great. Also, can HTTP only be set from the client side? So like, can I set a cookie that only is visible to the server and just magically disappear? And it seems like you can't. And also, if a secure cookie is set from HTTPS, this is going to be a long talk, then later overwritten with the secure flag from an HTTP page, which cookie will be sent in the request header? That I don't know, because different browsers does different things because they haven't specified it. And the same goes with the domain and the path, which has been the source of many hacks and security issues in the past. And even the thing with HTTP only had a few flaws. For example, in Firefox, when it was introduced, you could actually read the cookie if you did an AJAX request. So the XML HTTP request contained the cookie header, which contained the server-only cookie. And this only affects people who want to do bad things. For them, it's great. But we keep even if I don't know how to exploit most of the things, I can still keep my paranoid hat on and think that this is terrible. It's the same with the cookie domain and path. Are you all aware of how this works? The domain thing? I'll just skip through it anyways. So if I set a cookie on app.test.com, it's only going to be able to be read from app.test.com. It's the same if I then specify the domain app.test.com. It has the same result. So it defaults to that. But on app.test.com, where I'm at, I can also specify that I want to set the cookie on test.com. So it can be accessed from here, and from there. And this is sort of a really good thing, because that means you can share your cookie between different subdomains, like Google does for mail.google and docs.google and so on. But in the beginning, there was also some other conundrum, because the way when the specification was written, there were like 7 top domains. There was like com.net, .org, and a few more of them. So the way the specification is written is that they counted the number of dots from the end. And then there was a few exceptions, like co.jp, or later on like com.pl. And they sort of like skipped through the whole thing. So you could actually set you could actually be able to set a cookie for the whole country. And this is obviously not good. So nowadays, I'm welcome to correct me if I'm wrong, because I don't know if it's true, but this public suffix is sort of like the list that browser vendors are basing their cookie policy on. So they download a huge pile of top-level domain names that they're not okay with, or okay with setting cookies on. So cookies got something of a bad reputation, and it's partly well deserved. They were driven by can we do it, and also by advertisers, because they wanted their browser to be popular. But it also had a great help from other flawed parts of it. For example, if we imagine that HTTPS was a big thing at the time, and that was everywhere, we wouldn't have all those problems that we do today. If the secure flag in the HTTP only actually had worked from the beginning when it was specified, we would be in a totally different situation. But it's kind of hard to look at stuff like that when you're building something and look way into the future to what the web has become. I don't think they knew in '94 what we would be sitting here doing and talking about at the time. And also, we need to take a step back and consider it's not rocket science, because it isn't. But it's boring specification work that could be done better. So we get HTML5, which was a living standard, and in it came a few interesting things. Came the web storage API with the session storage and local storage. And session storage is something that back in when it was released, I heard from many backend developers that it's great, we can store session in it because it's called session storage. No, it's a storage that is only available in current browser tabs. So it's for people like me who tend to keep your browser tabs open at all times. Local storage is persists across all tabs and windows, and it never expires unless you delete it. But the thing that is common for this and not so common for the cookies is that they have a clear same origin policy. So meaning you can't store something on HTTPS that can be read from HTTP and vice versa. And it's also sensitive about subdomains and so on. So you're strictly within the same domain and protocol and basically everything else. And you can also store large chunks of data. And One thing that I at least found was really good about this is that it actually, when you set something, and it actually fires an event, which of course didn't work in IE when it came out, and I think it wasn't until IE10 that it was actually properly working, and then it was pretty flawed to build something on top of it. So, but what we really started to talk about here was the private browsing, the incognito mode, which is something that I think most browser vendors have. Firefox has it, Google has it, and Safari has it as well. And the idea is great. If you want to be surfing, you don't want to do some bank things, or like in Min Doctor could be relevant if you're searching for a disease or something. I would probably go into private browsing mode and then come out and be done with that session, because the idea is that the browsing session you have leaves no footprint on the machine. So all the cookies, cache files, and so on, they're not updated. And this concept is sort of like at odds with allowing pages to store things through local storage or local databases. So basically, to take it back in time, you have private browsing in iOS 6. It was good times. There was some cumbersome settings when this was introduced. You have this, like you go into Safari application settings. I was working on a company where we were doing mobile web apps in Safari. So this was I was really focused on these things at the time. So you go into application setting and you turn private browsing on, and bam, you have it. And you have it for all the pages you open until you go back into Safari settings and continue back to it. And a colleague of mine during this time, he was part working as a product owner. He loved taking screenshots. So all of a sudden, when iOS 6 came out, all his screenshots were in this blackish gray thing, because he simply thought it looked better. So he was using private browsing for the looks in the browser. He thought it looked better, and not thinking so much about like all the cookies were disabled and so on. And the thing is that it's been better in iOS 10, for example. Every time you open a new start opening a new window, you have this private mode toggle thing, which sort of makes it more conveniently. But still, if I started a private mode session and I come back on my phone and I open a link from an email, I'm opening that link in private browsing, which may or may not be what I want. So, and there's the cookie settings again. While reading up on this topic, I found an article on What Web Group from 2009, and they were talking about identified 5 different implementation strategies for handling local storage or handling storage during a private browsing mode. I think it's kind of interesting because there's been these 5 thinkings about it. One is to disable local storage completely, sort of like remove everything. When you go into private browsing mode, you can't do a local storage.set item or reach local storage at all. The other option they had was kind of disable local storage. So local storage, all the APIs exist, but it has a 0 quota, meaning you can try to write it to it, but it just throws an exception, throws an error. The third option would be to provide an empty local storage or empty storage. So when you go into private mode, you have local storage, you can write to it, but when your session ends, everything is removed again. And you can also provide a copy of existing local storage, where you get the old things back, and then you can write to it, but then it reverts to what you had before when you go out. And the 5th option was to have a read-only access to all your previous content. So I think I'm right to assume that this was the path WebKit chosen, or iOS chosen, and this is the path that Chrome and a few other ones have chosen later on. And if we take some private browsing objectives, I mean, what do we expect if we have a private browsing session? As a developer, I would expect maximum compatibility. I should be able to use local storage during that session, because that's my expectation. So that kind of rules out the completely disabled, kind of disabled, and the read-only access. And I wouldn't want anyone to know that I'm browsing privately, because that just feels stupid. I mean, the web, then the web page could act differently based on that, and that rules out, well, pretty much 1, 2, and 3 as well. And starting a session with data, I mean, that means that the site knows who I am, and that's almost certainly not what I want. And that sort of rules out number 4. Provide a copy and read-only access. So basically, it leaves us with to provide an empty storage, because that would be like you come in with a fresh browser and everything works as expected. And Safari is when you try in private mode to write to something, you get an exception, meaning that it's, you know, also you have all the APIs, but it also means that you can pretty much, if you check if you're on WebKit, then you can pretty much like do a try catch, and then you can figure out, okay, they're browsing privately, better do something else. So the reason I'm bringing up all the private browsing in terms of this is that we're pretty eager to adapt new things as front-end developers, and like 2-3 years ago, there was a lot of talk about a new kid on the block, but it's a really smart idea. But it's JSON Web Tokens, or JVT, or as they want to pronounce it, JOT. So I'm gonna be saying JOT. So not JOT, but JOT. And before we go into this, just a few words that I tend to mix up. So it's we have credentials, we have authentication, authorization, and claims. Credentials is a fact that describes an identity, sort of like your username, your password, or whatever you want to have. Could also be your fingerprint on iOS. Authentication is the act of validating a set of credentials to identify an entity. And the authorization is to verify that this entity, after I logged in, is allowed to access a resource or perform an action. And the claims are statement about an entity. So basically, I'm just going to skip about this, because JSON Web Tokens is a way of sending data which is digitally signed, or in English, it's a secure way to contain some data that can be sent over insecure URLs. And use cases for this is like authentication, single sign-on, emails with one-click actions, sort of like delete this comment or add this song to favorites and so on, because they contain everything that the server wants to know to securely do something about it. The key selling points behind JOT was it works in APIs. You can do cross domains. It can be stateless. You can easily scale it because you don't have to keep state on servers, and it's easier to maintain and debug because you can read what claims the cookie you're making. It's not a session key somewhere. It also has a built-in expiration functionality, and it's compact, self-contained, and it consists of 3 parts. It's a header, payload, and signature. And these ones are basically, the first part is the header that it contains saying that it's a JVT, it has a hashing algorithm. What kind of security do you want? The next one is the payload, and it contains the claims. So this one, this link here contains that my email is this, and I want to reset my password, and it expires in 2 minutes. And there are some standards for that. And the signature, in the end, is just a verification that and ensures that this message hasn't been tampered with, because it contains encrypted version of this data, and a secret that is on the server that only the server knows. So when the server gets this thing, it can be sure that things haven't been messed around with. And there's a website called jvt.io. It has a good debugger tool, and you can read a lot more about it. So basically, using web tokens is when a user logs in on a site. It can be anywhere. It could be on your web page or through Google or whatever. You get a JVT back, and this token must be saved locally, and that's where we get to the point, either local storage or in a cookie. And then the idea is that you send this through a header every time. And this sounds great, but the whole discussion has in the market has been around, well, we should use JSON Web Tokens instead of cookies. But it's not really right, because it's comparing apples to oranges. It's more like we should use JSON Web Tokens or sessions, or saying cookies versus local storage, because that's a storage mechanism. And the thing is that when we develop stuff on the web, we also need to be aware of it. We can do it by not thinking and just adapting whatever is out there. We also expose ourselves or our clients to different kinds of attacks, lethal attacks. This is like how most stock photography looks at hackers nowadays. And a few attacks that's been going on through history is man-in-the-middle attacks, which is sort of like eavesdropping when you're sitting on a public Wi-Fi, like here, for example, and you're browsing on HTTP. Then, if the guys at Foo Cafe would want to, they could use the router and see everything that's going on, unless you're using HTTPS. So always use HTTPS for everything you do. The second one that's really common is cross-site scripting, and that's sort of like that's all about stealing your session cookies, basically, or cookies, whatever. It doesn't have to be cookies; it could also be local storage or whatever you have on your machine. And it's all about trying to get something into a web page. Be it through comments or user input, or that you can write a blog post somewhere, and you can in other different ways inject stuff. And this cross-site scripting is really hard. As an example, there's a markdown parser called Marked on Node.js on the Node.js platform, but could also be used in the browser. Has like 2 million downloads a month. And they recently took them almost a year to fix it, but they had a cross-site scripting attack that was really easy to perform, and it's sort of built into the lovely HTML, which is very forgiving when it's when trying to figure out what the user actually wants to type. And without going too much into details, it's like you can use you can write a colon as a colon, or you can write it as ampersand #58 semicolon. But HTML allows you to write whatever you want to, because you don't have to. This one here is enough to write to get the colon. you don't actually need the semicolon, which some clever guy figured out, and I can write this there. And then I can, after that, I would have JavaScript colon this, doesn't do anything, and then I can write whatever I want to afterwards. And I can go in and steal all the cookies and so on. And this is really weird because that it's kind of a far-fetched thing. I mean, you just sit down and try everything out, but you can automate this, and there are a lot of tools you can download and just do a million of these tries on an application. The last one is I'm going to fix. It's a cross-site request forgery. CSRF, one-click attack, basically goes into that you want to trick the user to click a link or download or load an image, for example. And this image or the link you contain is basically taking you somewhere, taking the user somewhere where he's already authenticated and making them do something. And the user is trusted by the website, so any action they take is on the user's behalf. It can be really hard to find, and it always has to do what you have to send some extra piece of authentication in order for it to work. A lot of tools does this for you automatically. So in, for example, Angular and so on, there's some strategies for fixing this. You add some extra authentication when you post a form or something like that. So, some ideas of what to do. And browsing through some articles and so on, I stumbled upon an old movie called War Games from 1983. I don't know if you've seen it. It's kind of geeky, but it's a hacker who hacks with his really old backlit phone, and he starts playing a war game with a super smart computer that the US of A had installed in their as a security defense thing. And in the end, he says like, okay, the only winning move is not to play. And that is sort of true as well. I mean, the best we can do as front-end developers is basically to publish a static site somewhere on a CDN. Don't allow anyone to do any modifications whatsoever on it, and just display this beautiful website there. Second best, if that's not an option, always use HTTPS. And there are services like Let's Encrypt and so on that is free and scales really well, and so there's really no reason not to use HTTPS nowadays, especially not since we're talking about the service workers and so on. All of these things require it. All of the more, I think the browser vendors are calling it advanced stuff, is basically requiring you to do HTTPS. And besides, going back to the situation we had, or I had, or the reason I ended up here was that we have this situation, local storage is not writable. And the JSON Web Token idea kind of says that, okay, you need to store this token in local storage. You can't store it in a cookie because it's going to be sent on every request and you're open to this and that. And one of the solutions that we found was viable is to use the HTTP only attribute. And so you sort of have like a login.site.com, and the login sets an HTTP only one, and then you can automatically send this this cookie on every request to the API. And since JWT is more of like a way of storing data in a safe and tamperless way, I mean, the cookie could also be a bearer of this authentication token. And by setting HTTP only, we minimize the risk for cross-site scripting, because as an attacker, I can't reach this cookie. I can't see it. I can perhaps if I look at the network or something, but I can't do anything about it. This CSRF thing is still a risk, and I can't read the token. So everything in this JSON Web Token that is like my username, my profile, and so on, I can't actually read that data client side, which is one of the advantages for JSON Web Token otherwise. And also, in order to have an HTTP-only cookie, you need to be within the same domain in some way, like site.com. And another option would be, given that we can't use local storage in private mode, is to get the JSON Web Token back from a third party or something, at least an authentication thing that is outside of the domain setting. And I can store it in a secure cookie, and I can use not the cookie, but I can take the content of the cookie and send it when I'm reaching my API. Just as so I'm just using the storage cookies as a storage mechanism. That means I'm open again for cross-site scripting because it's a client-side cookie, and but I, as a client, can read what the token brings, which is good. It requires JavaScript because I need to convert this cookie data to a header, and but it also gives me the freedom to connect my authentication thing and my API to wherever. And this cookie is not going anywhere unless I'm doing a request on the same domain. Because if I move stuff to a CDN, for example, for CSS and so on, the cookie will not be sent there. So those are the different alternatives, and I would. Most people, most times it's like it's still even if after having been forced, I'm forcing myself to go through. I mean, to look around this issue here. It's like one question you could ask is like, if I don't have local storage available, in private browsing mode, should I be able to use the service? I mean, should I be able to log in? Should I be able to authenticate and do a private browsing mode session if Safari doesn't want me to? Because I'm basically putting a small percentage of our clients at risk by doing a cookie solution. But then again, especially when you have a service which possibly can contain some sensitive data that you want to be gone in the browser afterwards. So it's a way off, and that's one of the things that I'm hoping that Apple and Safari will be better with. I mean, to start comply with, start talking with other browser vendors more. All right. So basically, that's what I had. So thanks, and yeah.